Hello again, this is Mark Summers from Summers Technical Services. We're going to start on a new Solidworks model. We're going to do a DIN rail. DIN is a D-I-N, capital D-I-N. It's just a standard. It's like an ISO standard or a ANSI standard. It's a mostly European standard, and it's a component you can see on the camera here. This is the DIN rail, and it's used to mount different types of electronic components. In this case, relay socket, some relays, terminal blocks, and you can mount things like power supplies and just a ton of other stuff. And it's very versatile because these things just snap on and off. You don't have to bolt them down and unbolt them, drill holes. They just snap on and snap off. And so it's very useful. We're gonna model the DIN rail itself, and then later on in the semester we'll do a project where we will use that DIN rail to create a electronic assembly as part of our final design project. So let's go over here and look at the details of the DIN rail. And so here's our DIN rail. This is a cross section through. What you're going to do is go to the Googles and do a Google search for a NS 35/7.5 DIN rail. And those numbers relate to the overall width of the DIN rail and the overall height of the DIN rail. And you'll see that once you get to the data sheet. And the company that I want to use as a manufacturer, lots of people make these DIN rails because they're all made to the same standard. But Phoenix Contact is one I'm familiar with, so we'll use Phoenix Contact. So do a Google search on Phoenix Contact for an NS 35/7.5 DIN rail made out of zinc-plated steel and a length of 2,000 millimeters. And what we'll do is once we build a 2,000 millimeter long DIN rail, then we'll cut it to length to use in our design project. And it'll give you a spreadsheet with those values. So one of the things we want to do is we build this model. We're going to initially build a good model, but I want you to build a great model because that's the way we roll. And I want to be able to change the length of the DIN rail. Instead of being 2,000 millimeters, maybe we'll make it 1,000 millimeters. And if I change the length of the DIN rail, cut it in half, then I should have half as many slots on the DIN rail. And I don't have to tell the DIN rail to remove half the slots. DIN rail doesn't have a brain, but when I cut the DIN rail in half, it knows the piece that I've cut only has half as many slots, so I shouldn't have to tell the CAD model that I've only got half as many slots if I cut the DIN rail in half. And so we want to make a relationship between the length of the DIN rail, L, and the number of slots, which I call N. And our rule is we're going to cut wherever we cut the DIN rail, we're going to cut it right in between two slots. That's our cut rule. And since the slots are 25 millimeters apart, that means that cut is going to be halfway between those two slots, wherever we decide to cut it. And so what I want you to do is come up with a relationship between L and N. We shouldn't need to have two parameters, because if I change L, I should be able to compute what N is. I don't need two parameters, I just need one. And so you're going to come up with a relationship between L and N, and I want an equation for N that is a function of L. And based on the picture I drew there for you, I think you can figure that out. So that'll be part of what you do. You find the data sheet, do a Google search, find the data sheet, and once you find the data sheet, then you can go in here and come up with your relationship for n, equation for n as a function of L, and then we're ready to start the CAD model. So let's get started. So here's our CAD model, finished CAD model, and so it doesn't seem right to start from the finish line, so I'm going to say File, New. We've got our templates installed, so I'm going to use my millimeter part template, and I'm going to get my ISO view. I want my orientation of my DIN rail to look just like what you just saw on the screen there, so I'm going to go to my ISO view, and I'm going to see that I want to do my first sketch on the front plane and extrude normal to the front plane so it's oriented like I want. I want the bottom of the DIN rail to sit on the top plane, and I want the right plane to go right through the middle of the DIN rail. So with that in mind, I'm going to select front plane, I'm going to go to sketch, and I'm going to sketch on the front plane. And I'm going to do my sketch. I'm going to leave the fillets off because that's the way I like to do it. I don't like to do my fillets as part of the sketch. I like to do my fillets as a feature. And so here I'm being somewhat careful to draw my lines horizontally and vertically. And I think I'm doing a relatively good job here, but maybe I screwed up somewhere. Right click select to get out of the command. And so yeah, fortunately I wasn't paying attention. So I need to make a closed loop. You always want a closed loop for your extrude sketches. So I'm going to select one of these vertices and control click the other vertice, and then make a merge constraint to make these 2 points the same point. And click one, control click the second. They're both in the blue box, and I want to merge them. So that looks good. It's not great though. This line here should have been horizontal, so I'm going to select it, make it horizontal. I suspect you're going to be paying closer attention when you do your sketch, so you don't have to come clean this up. But in case you miss one, that's okay. Here it got kind of cattywampus, but if I drag that over, I get my closed loop. All right, this is why they call these things sketches. This is not an AutoCAD type drawing where all these line links are all the same. This looks horrible, but that's okay because it's a sketch. And what I want to do is like we did on assignment 9, which is drag a blue corner around and find something that needs to be fixed and then fix it. And so I can see that this line, and control click this line, these need to be collinear. And so I want to make them collinear and say okay, and then move on to the next thing. Well, what's the next thing? I have no idea until I grab one of these vertices and drag it around. This thing should be moving along with this thing because these are equal length. This is symmetric about this plane. And so I'm going to select this guy, control click this guy, and make these equal length. So I'm keep adding geometric constraints until the entire sketch is geometrically constrained. Well, here's another goofball issue. This thing right here should be moving up and down when I move this up and down. I can fix that by making this line and this line equal, or I can make it fixed by making this line collinear with that line. Doesn't matter which one you use. And so I'm going to select that one, control click that line, select equal, and as I add these constraints, you see them, they're showing up on the sketch here. There's equal, that's got a pair over here. These both highlight together. Here's another equal. Here's a collinear. And so these constraints, you need to get familiar with these symbols. They're kind of hieroglyphic looking at the beginning, but you'll get the idea after a little while. All right, now what? Well, I said I wanted my top plane on the bottom surface, and it looks like that point, the line, excuse me, is coincident with the origin. So that's good. That's why that line is black. But when I move this thing back and forth, this thing is not symmetric. And so I can fix this like we did on assignment 9 by adding a point and putting that point at the midpoint. If I get close to the midpoint, that indicator will change. Where in the world is it? There it is right there. Right click select. There's a midpoint of that line, and now I'm going to put that point, control click the origin, and make those coincident. now I've got this thing symmetric, so when I drag this left to right, that's taken care of. Well, what about this one? Well, that's not taken care of. This is not working out for me. I need to continue to add geometric constraints. And so I want to just add another center point, midpoint, excuse me. There's a midpoint, right-click select to get out of the command. There's the origin, control-click that point that's now the midpoint. Line those up vertically. Now we're getting somewhere. This thing is starting to behave itself like I want it to be behaved. Is it behaving geometrically like I want? I think so. I can't think of any other constraints I need, except I need dimensional constraints now. And so do your geometric constraints first, then do your dimensional constraints. So now I'm ready for dimensional constraints. I'm going to go to Smart Dimension. I don't go to corners, I go to edges. So there's edge there to this edge here. Click to place it, click to change the number, 35. And I hope these numbers are right. They're probably screwed up. But the data sheet, you got to find your data sheet. And then I want to go, as soon as this thing comes back to life, from this edge to this edge, I think it's 27. Click to place, click to change, 27. Here to here is 7.5. Now the thickness of this thing is 1 millimeter, and so I want to go from here to here. It starts off with a, whoops, that's not what I wanted. What the wild world of sports is going on here. Smart Dimension, here to here. There we go. Click to place, click to change, 1 millimeter. Here to here. It's also 1 millimeter. The thickness of the part doesn't change because it's stamped out of a single piece of steel. So all of these are going to be 1 millimeters. 1 millimeter. And I go around the horn here, and the thing's starting to turn black. Wait a minute. Fully defined. Why didn't I have to define this width here is 1 millimeter? Well, because of these other geometric constraints. So I want a minimum number of dimensional constraints. I don't want to have a bunch of numbers on here. I want to have geometric constraints and a minimum amount of numbers. And all these numbers are on your data sheet. No more than what's on the data sheet. So once you get fully defined, you can get out of the sketch. I'm going to do a space bar and do an ISO view. I want to pre-select the sketch, go to the Feature tab, Extrude Boss Base, 2000 millimeter depth. Boom, I got my first feature. Now it's time for the slots. Spacebar, I want to look down from the top. I want to come over here where the origin is, because I want a dimension from the origin to the slot. I want to sketch on this face right here, so I'm going to say Sketch. Come on, baby. I don't want to wait. Sketch, tab, sketch, select that face. Now I'm in sketch mode. I can tell I'm in sketch mode because of this and the buttons pushed down. Now it's time for a slot. I could do circles and lines, but I'm too lazy. I want to choose a straight slot. I want to click right there, boom. I want to click right there, boom, and I want to click right there, boom. Right click select. Now I've got my geometrically constrained slot. Now all I need is dimensions. So I'm going to go Smart Dimension. I want the width of the slot. And I don't remember what the number is. This is probably wrong, so don't copy it. Look at your data sheet. I want to go from, I want to dimension the length of the slot. This is 15, I think. I don't know. Check all these numbers. And I need the slot located to the edge. Well, I don't have anything on the edge here, but I've got this edge here that's not in the sketch, but it's part of the model. So I can dimension from this edge to the center of the slot. And if the slot distance is 25 between slots, I know that the slot to the edge is half of that because I want to cut the DIN rail in between equally distanced between each slot. Now something's wrong here. This dimension is 15 is correct, but it's not dimensioning to the center of the arc. It's supposed to be dimensioning to the total length of the slot. And so I'm going to select this dimension, and not knowing what to do, I'm going to right click on it, and I'm going to find, I want to select it, select it. I get my properties box over here, and I've got all kinds of options that I don't know what they mean. But one of the options here under leaders, arc condition, first arc condition, second arc condition. I don't want a dimension to the center. I want to go to the max. So watch what I click this button. Watch what happens. Takes me to the maximum distance, which is the quadrant of that fillet, or the radius. And I'm going to do the same thing for the second arc condition. And they're going to both pop to the outside edge there. That's what I want. And now the number's not right. I want to go back and put the number in as whatever the number is. That may or may not be right. And so now what do I have? I have a beautiful thing because it's fully defined now. 3 dimensions, that's all I need. I don't want a bunch of extra dimensions. I want everything to be geometrically constrained. Now I'm going to spacebar ISO view, and I'm going to look down on this thing. And now I'm going to do an extrude cut. So I'm going to select the sketch. I'm going to go to features. I'm going to do extruded cut, and it's going to go 1 millimeter through, but that's not my design intent. My design intent is through all, in case the thickness changes. So now I've got 1 slot. So I've got to do this 79 more times. There's 80 slots in a 2,000 millimeter long DIN rail, and it seems ridiculous to do the same thing 79 times more. And so I'm going to do a pattern instead of doing that. Patterns seem like the way to do it. So I want to pre-select the sketch. I want to pre-select the feature. The sketch is underneath the feature. And these are all fully constrained because there's no minus signs. So I haven't lost 5 points yet. So I'm going to pre-select this feature. And I'm going to come up here and find linear pattern. There's lots of patterns, but the one I want is a linear pattern. And I've already pre-selected the feature. And so there, it knows which one I want to extrude, want to pattern. Direction 1, I have to somehow define direction 1. And I can define direction 1 by the front plane. I can go perpendicular to the front plane. I could grab this edge. That edge is also along the direction I want. So any kind of feature you can find that will define the direction. And now I'll come down here. It says, what's the distance between each instance? Well, it's not 10, it's 25. And it gives me a nice preview, and there's 80 of them total, and so I'm done. Boom. And so now that feature gets replicated 79 more times, 80 total. And now it's a beautiful thing. It goes all the way to the other end down here. All right, now what do I need? Well, I need these fillets. And so we've got 4 inside bends and 4 outside bends. And so you need to be able to figure out what those values are. And so you're going to go to your fillet command, grab the 4 inside edges, and remember you can grab these edges. I can see that one, so I can easily grab that edge and group all these together. Group the 4 inside bends together, have another fillet command to group the outside. I can't see that outside edge here, but if I can look through it with my mouse, and there's the edge right there. So I got inside, inside. I can't see this one. I could spin it around, but you know me, I'm lazy. And so there's an inside edge, and there's another inside edge. So I got all 4 inside edges. The inside fillet, inside bend radius is not defined on the data sheet for some unknown reason, but it's 1 millimeter. Now you're going to do the outside bend radius. We'll do another fillet command. And then you're going to apply your material based on the data sheet. And then you're going to be done with part 1. But part 1 is going to get us to what? It's going to get us to a good model. I want to make this model so that I can change one global variable and have this thing update the length and the number of slots at the same time. So once you get through with this in class today, I'm going to pull the trigger and show you how to turn it into a great model so that we can have a great model. Why have a good model? Good models are good, but we're not going to deal with good. We're going to deal with great. All right, so that takes care of preliminary discussions about assignment 10, our beautiful DIN rail. So thanks for watching. Subscribe, hit the subscribe button. I got great videos coming out every week. You're going to want to see them. Hit the subscribe button, hit the notification bell for all, and make my day. So thanks for watching, and we'll see you on the next one.